Hello students, let us start our discussion about free fall. जैसा कि हम जानते हैं, यदि किसी ऑब्जेक्ट को कुछ ऊंचाई से छोड़ दिया जाए तो नीचे की ओर गिरते समय ये कुछ स्पीड अटेन कर लेगा और कुछ हाइट ट्रेवल कर लेगा, ठीक है। और अगर इसको हम एकदम इनिशियल स्पीड 0 से छोड़ें तो थोड़ी देर बाद ये टकराते समय, पृथ्वी से टकराते समय कुछ पर्टिकुलर वेलोसिटी गेन कर लेता है, ठीक। वो उसकी फाइनल वेलोसिटी होती है और जिस वेलोसिटी से इसको हम रिलीज करते हैं वो उसकी इनिशियल वेलोसिटी होती है। अब अगर हम किसी ऑब्जेक्ट के बारे में बात करें जिसको हम फ्री फॉल करवाना स्टार्ट करते हैं तो ऑब्जेक्ट नीचे गिरते समय कितनी वेलोसिटी अटेन करेगा और कितनी हाइट वो ट्रेवल करेगा ड्यूरिंग फॉल, फ्री फॉल, और कुल कितना समय टेक करेगा, हाउ लॉन्ग इट विल टेक टू रीच फ्रॉम द maximum altitude to the bottom. Okay, so all these can be easily calculated with the all three basic equations, that is also known as kinematic equations of motion, which first v equal to u plus at, and second is s equal to ut plus half at square, and the third one is v square equal to u square plus 2as. Okay, so all these three equations helps us to determine the value of u, s, a and t during the motion or uniform motion. Okay, so if we take any object is freely falling under gravity, then the acceleration, that is a at here, can be replaced by a particular value, that is g, that is gravitational acceleration. So all these equations will change and can take a different form. For this, suppose that this is a point from where any object is freely fall, and the height from where the object is falls is h, and the initial speed at the highest height, maximum height, that is 0, by which object is released, that is object is released freely from this point. And suppose that during falling, if object travels a small distance h, suppose that in time t, then let us suppose that the gravitational acceleration by which the object is falling down is small g. Then if the object is moving down, then suppose that in time t the particle will attain a velocity v at this point. So if we relate all these u, v, g, t, then we can easily obtain a formula for v during free fall from the first equation of kinematic theory, which is v equal to u plus at. Then the equation for this will be equal to easily obtained by placing a with g, that is u equal to v equal to u plus gt. Okay, this a is replaced by g, so this becomes v equal to u plus gt. Similarly, if we want to calculate the second equation for then the height or the depth which falls the ball or object during time t is small h, and the total height attained by the ball in capital S, suppose that, then this h can be expressed in terms of u, v, u, t and g, like h equal to ut plus half of gt square. Okay, this is the equation. The third equation, v square equal to u square plus 2gh. Okay, so with the help of all these three equations we can easily solve different types of numerical problems. Suppose that any object is falling from a height of h, then the velocity attained by the particle which increases if we throw that particle vertically by a initial velocity u. Suppose that in case in which the initial velocity is non-zero, so the velocity during falling is non-zero, it means initial velocity will be taken and by taken fixed quantity. Okay, so u it can be used in the formula when the object is thrown vertically downward by a fixed value of velocity. So these three formulas are helps to find out to solve the different types of numerical problems based on the object under free fall. Okay, और मैं अगर किसी ऐसे ऑब्जेक्ट के बारे में बात करूं जो ऊपर की ओर फेंका जाए, सपोज दैट इस ऑब्जेक्ट को, इस चाक को मैं ऊपर की ओर एक इनिशियल स्पीड यू से थ्रो करता हूं, तो ये ऊपर की ओर जाते समय भी नीचे की ओर लगने वाले एक ग्रेविटेशनल एक्सेलरेशन से अफेक्टेड होता है और एक पर्टिकुलर टाइम में ये मैक्सिमम कुछ हाइट अटेन करके वहाँ पर क्षण भर के लिए रुक जाएगा। अब क्यों ये इसका रुकता क्यों है? क्योंकि ऊपर की दिशा में जाते समय भी नीचे की दिशा में एक ग्रेविटेशनल एक्सेलरेशन वर्क करता है। चूँकि इस एक्सेलरेशन की डायरेक्शन वर्टिकली डाउनवर्ड होती है और हमारी इनिशियल स्पीड की डायरेक्शन वर्टिकली अपवर्ड होती है, इसीलिए ये एक्सेलरेशन एक डिसेलरेशन की भांति बिहेव करता है जो हमारे वेलोसिटी को कंटिन्यूसली डिक्रीज करता है, अर्थात एक मैक्सिमम हाइट पर जाने के बाद ये वहाँ पर क्षण भर के लिए रुकेगी और वेलोसिटी डिक्रीज कर रही है तो ऊपर जा कर के रुकेगी और नीचे गिरते समय इसकी वेलोसिटी लगातार बढ़ती चली जाएगी। ठीक, तो इस प्रकार से आपने देखा जब किसी ऑब्जेक्ट को ऊपर की ओर थ्रो किया जाता है तो ये एक मैक्सिमम हाइट पर पहुंचने के बाद रुक जाती है और वापस गिरते समय अपनी वेलोसिटी को लगातार बढ़ाती चली जाती है। चूँकि किसी ऑब्जेक्ट को जब ऊपर की ओर थ्रो किया गया था तो इनिशियल वेलोसिटी को यदि मैं पॉजिटिव लूँ और नीचे की दिशा में लगने वाले एक्सेलरेशन को निगेटिव लूँ तो ऊपर की दिशा में जाते समय ये अपनी वेलोसिटी को कंटिन्यूसली डिक्रीज करता है और साथ ही साथ ऊपर पहुंचने के बाद जरा देखिए, अगर इनिशियल वेलोसिटी किसी ऑब्जेक्ट की मैं u द्वारा प्रदर्शित करूं तो u हमारा पॉजिटिव लिया जाएगा तो ग्रेविटेशनल एक्सेलरेशन g नीचे की ओर काम करेगा और इसको हम निगेटिव लेंगे। ठीक है, तो ये हमारे वेलोसिटी को डिक्रीज करता है। तो अगर मैं इनकी सहायता से इन तीनों इक्वेशन में g को निगेटिव रखूं with respect to g, then we find v equal to u minus gt and from here h equal to u minus half ut minus half gt square, and third one v square equal to u square minus 2gh. So we can find all these three new different equations if we place the minus of g on place of g. Okay, so this is the different equations of the kinematic which will be used in the free fall. Now let us take an example in which suppose that any object is thrown vertically in upward direction by an initial speed of 25 meter per second and the height attained by the object is h, suppose that, and the gravitational acceleration acting on the object is continuously constant, that is g equal to 10 meter per second square. Okay, so the value of g can be taken is negative and initial speed can be taken as positive. The height attained by the particle is equal to ut plus half gt square. Now as we know that at maximum height the velocity becomes 0, so v square equal to u square plus 2gh. If we put g as minus of 10 meter per second square at here and the velocity, initial velocity by which the object is thrown, u is plus 25 meter per second, and then we can calculate at here how much height can be attained by the object, because at maximum height the velocity becomes 0. So if we put the value of v at here as 0, then what will be the maximum height attained by the object? So it can be easily calculated putting the value of v as 0 in this equation. So we get v as 0, so v 0 square equal to 25 square plus minus twice of minus of 10 into h. So from here we got minus 20h, so it becomes plus 20h equal to 625. So h equal to 625 equal to 20, that will be equal to 62.5 divided by 2, that is 31.25 meter. So the maximum height attained by the particle to obtaining its maximum velocity at 0, that is equal to 31.25 meter. Okay, so object will move and travel some height during its motion. Now what will be the time to reach at its maximum height? So it can be easily calculated, the first formula, that is equal to u plus ut. So from here 0 equal to 25 plus minus of 10 into t. So from here t equal to 25 by 10 t equal to 25, so t equal to 25 by t 10, that is 2.5 seconds. So object will attain the maximum height in 2.5 seconds only. Okay, so object can attain this maximum height in only 2.5 seconds. Similarly, if you want to know what will be the displacement of any object at any time 3 seconds, suppose that, so what will be the time, what will be the value of height at t equal to 3 seconds? So it can be easily calculated as h equal to ut plus half of gt square. So if we put the value of t as 3 at here, then h equal to 25 into 3, okay, plus half of 3 is minus of 10 into 3 square. So it becomes h equal to 75 minus 1090 divided by half, that is 45. So 75 minus 45, okay, that is equal to 30. So the object will attain the maximum height as 30 meter after time 3 seconds. It means it will attain its maximum height and then returns back by a small difference or a small distance falling down. So it will attain a total displacement of 30 meter after time 3 seconds, and at 2.5 seconds this will attain 31.25 meter. So it means clearly in 3 seconds object will returns of its motion from its maximum height. Okay, so this is all about the free fall and the application of the kinematic equation of the free fall, and you can utilize all these equations to any object moving vertically upward or falling down or downward. Okay, so you can utilize all these 3 equations to solve different types of numerical problems and many other situations. Suppose that any lift is free falling under gravity, then what will be situation for a person placed in the lift? उसको ऐसा प्रतीत होगा जैसे उसके पैर के नीचे से ज़मीन ही खिसक गई हो, अर्थात वो वेटलेसनेस की कंडीशन में आ जाएगा और एकदम फ्री फॉल करता हुआ नीचे की ओर गिरने लगेगा। इसी प्रकार आप किसी बिल्डिंग की ऊंचाई से नीचे की ओर कूदें तो आप ऐसा ही महसूस करेंगे। ओके, दिस इज